Hello everyone, this is going to be the review on the Intocircuit T5000. Inside the box you will find the T5000, the operation manual, and the carrying pouch. These are tipped for various different kinds of phones, PSPs, tablets. This is a cable to go with this, and this is warranty card. The included adapters that come with the T5000 is a mini USB, a Nokia adapter, a PSP adapter, a micro USB for Android phones, 30-pin dock connector for older iPhones like the 4, the 4S, and iPads, and this is a Samsung proprietary connector. We will now take a closer look at the T5000. On the left hand side, you'll see the micro USB charging cable for the T5000, a power button, 5 indicator LEDs which light up blue, as you can see there. On the top, you'll find one 5V, 1A output, and the flashlight. There's nothing on the back or the side. At the bottom of the unit, you will find the model number, T5000, the capacity of the two batteries, which is rated at 3.7V, which is 5,000 mAh, at 18.5 Wh at 3.7V. The input is 5V, 1A. Max output is 5V, 1A. The Intocircuit T5000, you will need to press and hold the power button for 2 seconds. As you can see, it will turn on the boost converter and it will show the amount of battery left. Right now it's at 4 out of 5 bars. Right here I have a charger adapter which measures how many amps and volts the T5000 outputs. Right now it is outputting 0.32 amps at 4.8 volts. Powerbank is made for Apple devices, so it will not charge Android devices at full speed because the data pins are not shorted. It is easy to get a charging only cable for Android. There is one thing I do not like about this T5000, which is the indicator LEDs. They never turn off and they just sit there and waste battery. We will now take a look on how well is the power bank design inside. When you take the cover off, you will find two 18650 2500 mAh batteries in parallel, which means their milliamp hours double or add up, which equals to 5,000 milliamp hours at 3.7V. On the front where you plug in your charger and your phone, you will see two boards. On the daughter board, you will find the 5 indicator LEDs, a push button, 2 connectors to connect to the main board, and a unmarked chip to prohibit other manufacturers from copying and cloning the device. On the main board, you will find the 18650 batteries, which are wired in parallel together. And right here, you will find the DW01A protection IC chip. DW01 chip is designed to protect lithium-ion and lithium polymer batteries from damage or degrading the lifetime due to overcharge, over-discharge, and overcurrent for one-cell lithium polymer batteries. Because these are wired in parallel, they act as one big cell. Next to the DW01A, you will find the ML8205A, which is a dual MOSFET that controls the batteries. The MOSFET's main purpose is to switch the output and the battery on and off. In case of a short circuit, the DW01 chip will tell the MOSFET to turn off. It will shut power to the whole board. Any USB powered devices will require 5V to operate. Because of the battery's parallel configuration, you will get 3.7V at the output of the batteries. In order to get 5V, you will need to use a boost circuit. Using a boost circuit, you will lose efficiency, but you will gain voltage. Max efficiency achieved charging iPad Air was 65.2%, and the max efficiency for the Nexus 5 Android phone was 72.2%. I was only able to get 3,380 mAh out of the USB port. That means input is 5,000 mAh, output is 3,380. That equals to efficiency of 67.6%. I cannot recommend this power bank to anyone because of the very low efficiency and the charge rate.